So now we will talk about quantum numbers. Like what are quantum numbers? Like in my previous video, I'm done with the introduction of quantum mechanical model or wave mechanical model. So now let's talk about quantum numbers in detail. So what does the quantum number show? So actually quantum numbers tell you the not exact the probable location of electron, like where there is high probability of finding electrons. So 90%. So quantum number shows you that the location where there is high probability of finding electron. So we are having 4 quantum numbers. Number 1 is N, L, M and S. So N is principal quantum number. L is azimuthal quantum number, or you can also say angular momentum quantum number to this, or it is also known as subsidiary quantum number. M is magnetic quantum number. It is also known as orbital orientation quantum number. I will write in when we will go in this detail. S is known as spin quantum number. So these show the address of the electron. For example, the planet in which you live is Earth. The country, like I live in Pakistan, so that's my azimuthal L. So in Pakistan, in which city, in Mepakhas, and the S will be the address to my home. So this shows the location of the electron, the highest probable location of the electron. So now we know that electron is a wave, right? And the probability of finding electron is orbital. Like what is now orbital? So orbital is a 3D space where finding of probability of finding electron is highest. So electron moves. Electron is a wave, so obviously it will move in a region, in a space where the probability of finding electron is highest. That space is known as orbital. So these quantum numbers actually tells you about the orbitals, the size of orbital, the shape of orbital and the orientation of orbit. So these 4 quantum numbers actually tell you the size, shape and the orientation of the quantum number. So now let's discuss the first quantum number. The first quantum number is N, is known as principal quantum number. So it actually tells you about the shell. Now N is equal to 1, N is equal to 2, but N is not equal to 0, N equal to 3, N equal to 4, N equal to 5 and N equal to infinity. So this actually tells you about the number of shells, where N is equals to K, 1 is equals to K, 2 is equals to L, 3 is equals to M, 4 is equals to N, 5 equals to O and infinity. So it actually tells you about the number of shells, like 1 is equals to K, L is 2, M is 3, N is 4, and this is a thing which is written in your book. But the actual thing, which actually, like, what is the meaning of what does actually the principal quantum number tells you? It tells you about the size of shell. Like how when you go away from the nucleus, like this K is near to the nucleus, right? But when you go away from the nucleus, the size of the atom, the size of the shell is increasing. So the shell, as you move far from nucleus, the size of the shell increases. And it also tells you about the energy of shell, like how when you we know that the shell near to the nucleus is having low kinetic energy, low energy, but the shell which is far from the nucleus, for example O, is will be having highest amount of energy. So the energy also increases when we move far from the nucleus of an atom. So we know that the formula of energy is energy of nth shell is equal to minus 13.6 Z square upon n square electron volt. So this formula was given by Bohr and it is still valid. It is used to find the energy of the electron in nth shell. So as you know that when we are moving away from the nucleus, right, so the size of the shell is increasing, the energy of the shell is also increasing, means distance is increasing. So what does the principal quantum number actually tells you about? So the principal quantum tells you about the size of the shell, the energy of the shell, like this is the formula, the energy of electron in nth shell is minus 13.6 Z square upon n square electron volt. It actually tells you about the distance.